hold on, don't start this video without watching the intro, or none of this video will actually even make sense to you. So first, you need to be aware that this video is one of 6 sections, okay? This course was designed for those like me who always seem to watch videos, copying what the video is doing, and then not learning anything. This frustration stayed with me for years as I was trying to learn the game development and coding. So many years later, here I am, trying to bridge that gap in the game dev community. I've been teaching for quite a while on YouTube, and this course I've been working on for quite some time, and I've planned it for quite some time. So the question is, after this, is how does this course work and how is it structured? Firstly, you need to understand and that to learn and how to code game development, realistically, you need to simply do stuff and create your own projects. This is why generally you or other people will look for tutorials and copy them, right? However, I've structured this course in 6 sections because of that to some extent. We have platformers, we have RPGs, shooter games, tower defense games, turn-based games, and RTS. Each section, excluding the platformers, will have a 2D and 3D section. And as you might be able to tell, there are different genres of all these games. So all these sections are different genres. And I've ordered them from easiest to hardest. Of course, this doesn't mean that all platformers are easy to make, but the general idea is still that it gets increasingly harder as you manage to move along the course. Right now, you're watching the platformer section of this course, and within each of these sections, there are 3 subcategories that we'll be going through to understand the basics. The best way that I've found that people learn, and the best way that I can teach you is through a 3-step process. And I've researched this quite a bit, and I think this is the best way in terms of game development. You teach the concept, you show an example, and then you give an exercise. Usually, the reason why you find it so frustrating to learn and you're so stuck on things in YouTube is because you are only given the example. Sometimes you are given the explanation of a few things, but generally speaking, you are only given the example. And so it gets really tricky and hard to understand what is even happening. So throughout this video, you'll be doing exactly that. You'll be going through the concepts of platformers, how they work, and how the physics of all of it works. We'll be going through various examples throughout the concepts as well, so don't worry too much. Not only in Godot, but also on a whiteboard. So we'll be going through the concept on a whiteboard, and then I'll be kind of showing you some small examples, and you'll kind of see how it goes along. But it's going to be mostly a watch along. You can follow along on Godot as well, which actually I do encourage, so totally do that. And then later on, there will be an assignment that I encourage you to download below. It will be in a PDF file. I really do encourage you to download it. I do have a short video in the middle. It's I think 6-7 minutes long, explaining the assignment and how you should go about it. But at that point, I really do encourage you to just stop the video, like close the tab and just work on the assignment yourself, okay? Lastly, I just want to thank my Patreons for supporting me and actually allowing me to find the time to work on this course. Keep in mind that this section of the course is free. However, if you would like to support the development and continuation of this course, and you really like the way that I have structured this, please do consider supporting me on Patreon. And of course, the rest of this course will be sold on Udemy. Maybe my website, we'll see eventually. So if you're watching this and it's far into the future, it might already be available, so do check it out. Of course, you can still support me on Patreon, especially if I'm still active, which I hope I am. And yeah, good luck, my friends, and stay coding. Welcome, everyone, to your first lecture of this course. We're going to first go over a bit of the main topics that we're going to talk about in this section of the course, which is the platformer. We're going to go a little bit in depth in the exercises and the examples, but first I'm just going to give a brief overview of what we're going to actually learn. So first we're going to learn about the positions of 2D and 3D spaces and what those spaces actually entail. And then we're going to go into velocity and movement and how to actually move an object, right? And then we're going to get into jumping and how to actually kind of defy gravity, or what gravity even is. So we're going to kind of go through those 2 things. And then we're going to cover some other relevant topics that will be covered mainly for the exercises. And additionally, just keep in mind, which I'll probably mention later, but the additional components that we talk about are going to be specifically for Godot. If you want to apply this to any other engine, you will have to learn more about that engine and the things that it uses. But generally speaking, there is a similar format amongst the game engines that we use. Welcome everyone to your first lecture on positioning in Godot. We're going to talk about positioning in general, and then we're going to kind of relate it to Godot. So first, we're going to look at some graphs and understand how this works in Godot. So if I can just draw, please. Whoops, I think I need to actually select the brush. So we'll select the brush, put 2D and 3D over here. So let's take a look at 2D first. So generally for 2D, we have something called a graph, right? So we have the x-axis over here and the y-axis. Now, generally, we have the positive and positive over here, right? So we go positive in the x-axis over here on the right, and then negative on the left on the x-axis, and similarly on the y-axis, right? However, in Godot, we actually have these reversed. Now, this is specific to 2D, okay? Let's keep this in mind. In 2D, for Godot, the x and y-axis, well, the y-axis is reversed. So the top is negative and the right is positive. So the x-axis doesn't change, but the y-axis is positive on the bottom. Now, the reason this is done this way is because the way we look at the Godot project is we generally look at this area usually, okay? So that's kind of, I think, why they set it up that way. But let's take a look at some positioning. So if I had a player over here in the middle, and I wanted to move it to position 100, or I won't actually give the position. I want to move it over here, right? Over here. And let's say this is 100, and this, because this is positive, this is also 100. Right, let's extend the graph a little bit. So this is position 100, this is negative 100, and this is also negative 100 over here. Now, if I want to access this position or move this ball to this position, how do I do that? Well, first of all, I want to be able to know what position this is. How do I access this position? Usually in math, we can access this through a set of coordinates, right? So we call it through the x and y coordinate. Now in Godot, it's similar. In programming, it's similar. So it's a very similar concept. So what we're going to do is we're going to call 100 for the x and then 100 for the y, right? Because this is positive. Now in Godot, we usually call it by saying vector 2. Now in Godot 4 specifically, there is something called vector 2i that they introduced, but I'm going to say don't worry about it. It's basically the same. It is mainly there for optimization and programmers who want to use vector 2i in specific cases. So don't worry about it. Just use vector 2 when we're accessing a position. Now, if I want to move this ball or this thing, I have to access the position of this thing. Now, how do I do that? Well, let's say it's a ball. Let's say we call this object called a ball. And now we want to put a point here or a dot. This will allow us to access any sort of property that this ball has within it, right? So let's say this ball has a position. It has a name. It has, let's see what else, a type, which I think is actually a thing in Godot. It also has, let me think. I don't know. I think this is enough to understand the idea. So basically, the ball or the object, and this is true for all nodes in Godot, most nodes in Godot have these things called properties. These are properties, okay? So properties. Now, if I want to access one of these specific properties, I would call the object first, right? So ball, right? We have to make sure that this is called a ball, and we'll see how we actually access a node in Godot in a minute. But this is what we want to do. We want to access the node, and then we're going to call the property that we want to change. In this case, we're going to change the position. So we call the position, and then we're going to make it equal to vector 2
to 100, 100. Now this is how we would change the position of the ball, right? Right here. Now in the 3D space, this is very similar. However, two things. The Y position is back to normal, and we've added a new line, which is the Z coordinate, right? So this is 0, 0 over here, and this is positive, I'm sure, and this is negative, I think. We'll double check in Godot in a minute. And this is positive. So if I wanted to move something, let's say over here, which is kind of weird to see, but let's say this is 1, 1, 1, right? Or 100, 100, 100, whatever. We would want to do a similar effect as we just did here, but we would be working with vector 3. Okay, so we have vector 3, x, y, and z. So it is the exact same thing. However, in Godot, there is a few extra properties. I'll double check and I'll put them in the Word file for you to double check, but there are other things called transform. It just makes easier to access, transform. I think there's also origin. It makes it easier to access the vector 3, okay? But in general, we can do the same thing that we do in the 2D space. So let's take a look at Godot and let's go through some examples of how we can actually do this. All right, so in our Godot project, we're gonna use this sprite 2D to represent our object that we're gonna move in a 2D space. Now, I also have a node as a base node in Godot in order to actually put things into our seed. Okay, so when I play, we can see that our icon is over here on the top left. Now, we want to move this to position, let's say 250 and 250. Now, I want you to try to do this first. If you can't, that's okay. We'll go through it together. So the first thing we want to do is attach a script. Now, there's something called built-in script and non-built-in script, right? We can uncheck it or check it. Now, the difference is, you can read it, but basically, if I don't have this checked, I can actually create a script and it will go into my files. However, if I don't have this clicked, or I do have it clicked, it will not create a folder. Now let's create this and see the advantage of this. If I hit Control-Shift-F, I can find in my files, let's say process. We can now see that the process function exists in this script. Now, if I had it built in, it would not work, right? This would not have allowed us to do that. Now, we're gonna move our position in the ready function. So in our ready function, let's try to access this node, this object. Now, how can I do that? Well, it depends on where my script is. So in Godot, the way we access nodes is generally through the positioning. Now, if my script is on the node that I want to move, I can just call self. We'll say self.position equals vector 2, and you can see it's going to complete for us. And we're going to say 250 and 250. Now, another way we can do this is if we actually take the PodQuest transparent, and drag it in, you'll see this little key or this $sign, and it's going to access the node, right? Now, let's say we wanted to access this other node that exists. We'd do same thing, and it would allow us to access that node itself, okay? Another way, a third way, is to use get node, and this would be our self. Now, this is probably my favorite way of doing it. This is how I do it, but again, I'm showing you the 3 ways of how to access a node or an object, and that's it. So let's take a look at what we get. And there we go. We've moved our node. Now let's take a look at 3D. So let's go to 3D. And we gotta delete this actually. Otherwise, when I play, it will play in a 2D space. So let's add something here. Let's add whoops, that's not how I add a node. Let's go to here and add a child. And what we're going to do is we're going to add not a collision. What is it called? Let's search up shape. Here we go, mesh instance. Now we're going to give this mesh a box. So it actually has a box. Now here we can see in the transform, the position, we have X, Y, and Z. Now I want you to try to pause and try a similar thing. However, to challenge you this time, I want you to add the script to the node. And I'm going to make this built-in. So pause here. Okay, now you can pause. I want you to try to move this mesh instance to 250, 250, 250. Okay? And don't play yet because there is something we have to do. Because if we play, I'm almost sure, yeah, it will show us a 2D scene. So let's make sure that we add our script. So hopefully you've tried this by yourself. And let's do this together. We can actually copy this and go over here. And instead of self, I'm going to access this guy. And now we see that we get the mesh instance. And now instead of vector 2, we want a vector 3. And we're going to move it to 250. Whoops, not dot. There we go. So 250, 250, 250. Now, let's actually move this to 250 and see what we have. Let's say 250, 250, 250. Now, if I zoom out, we can see that it's somewhere over here. Now, that's actually really far. So let's actually change it to 225 maybe. And let's reset this. And now what's the thing that we need to add in order to make this work? Well, let's make this a little bigger first. Well, we need to add a camera 3D. So let's go over to our nodes and add a camera 3D. And here we go. And we're just going to move this outwards a bit. So that way we can actually see what's happening. Now, if we zoom in, we can see where it's going to be pointing, right? It's going to be pointing that way. So let's move it this way a little bit. And then let's play. Hopefully we'll be able to see it. There we go. There it is. Let's try one more time, but let's delete this to make sure that that actually did move our object. Okay, well, in this one, it's over here. And if I add the code again, it's over here. So it has moved. Awesome. Now, it's obviously a little difficult to understand or see this in the 3D positioning. There's a lot of reasons as to why, but don't worry. We're going to go into 3D environments and things like that in the next section of this course, in the 3D section. So for the platformer course, or part of this course, you're going to focus mostly on the 2D section because you need to understand how positions and things work in the 2D space first, and then we'll move on to 3D positioning. Okay, welcome back everyone. This is lecture 2. In this lecture, we're going to learn about how to actually move positions. The basic idea is we want to move an object from point A to point B, right? And we're going to do this in the X and Y coordinates, okay? So the basic idea of how we're going to look at this is the X and Y here are going to be A, X, A, and Y, A. This is going to be X, B, and Y, B. Now, what does this mean? The basic concept of positioning in 2D is we want to move something, an object, generally from point A to point B using the X and Y coordinates. So on an X and Y graph, remember this is the negative and this is the positive for the X and Y. Let's say we want to move down from, let's say here to here. Okay, so let's say this position, we'll say this, we want to move from position, let's say 10 and 100 to position 100 and 100. So we're moving basically to the right. This is a rightwards motion, right? We can see if this is our screen, right? We're playing a video game. We're moving our player to the right, right? That's how it works. So how do I do that? Well, in game engines, in general, we want something called a tick. We want a timer, basically. Every time this timer ticks, right? Let's say we have a line, and we have ticks every second, right? So here, 1 second. And we have a tick, 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 tick. And this is all 1 minute. So we have 60 ticks a minute, something like that, okay? Every time we tick, or every time the timer goes off,
we want to change our position. So the way we can do that is we basically want to take our X position and plus equals, let's say 10, for example. So now question to you, how many ticks would it take to go from here all the way here? Well, 10, right? If 10 ticks go off, then we'll have moved from position, well, actually 9, I guess, because we're at 10. Sorry about that. So it'll take 9 ticks to go from position 10 in the X coordinate to 100, right? Now, the question is, how do we use this tick in Godot specifically? Well, we'll get into that in a second. I'll show you an example of how that works. But basically, let's give one more example of how we can move an object in the X position only, right? Because in the last lecture, we looked at how we can move positions, but how do we access the X coordinate only, right? So let's say from our last example, in our last lecture, we used self, right? So we're going to use self. We're going to use our own object to move. And again, remember, the self, an object, consists of many different properties, right? We have name, position. Another one I remembered is rotation, right? There's so many different properties. Now, in order to access one, we say self.position. Now we say self.position to access the position, but here's a question. In position, does position have properties? Well, I think so. I think it actually has its own 2 properties. It has an X and Y, because this position is consisting of vector 2, an X coordinate, and a Y coordinate. So the properties of our position consist of 2 sub-properties. There's an X and a Y coordinate. So I can access that by saying .x. And now I can add by saying plus equals, let's say 10, for example. Okay? Now I don't have to say vector 2 like this, or whatever, while this is an option. This is usually how we do it, by just saying plus equals 10. Now, another way that you might have realized, so let's say 10. Another way we can realize is if we say self.position, we can actually, we can actually add to the X position of this position by saying vector 2, 10, and 0. That way we're adding to the X, but we're not adding to the Y, right? We're adding 0, right? So you have 2 options. This is option 1, and this is option 2. Let's say option 2 like that. And I personally kind of rotate between the 2. I don't have a preference. It's really up to you and how you like to do it. I would say in general, I tend to use this one a bit more, because when I read the code, it allows me to understand what is actually happening, because we read it from in English at least, we read from left to right? So we read self.position.x. Okay, well, that tells me I'm editing the X position of this object, and then I'm going to add 10. Okay, now I understand. Whereas here, I would say, okay, I'm going to access the position. Well, what am I changing? Well, I don't know yet. Okay, let's go over here and actually read this and understand this. Well, okay, well, I'm changing 10 in the X. Okay, so I'm changing X position of this object. So it's a bit more not as intuitive as this one would be, as option 1. So I will suggest, for your sake and others' sakes of reading your code, I would suggest using option 1. However, in the end, they are the same thing. So let's actually head over to Godot and check out an example of how that works. All right, so in Godot, we want to move our object here, let's say 100 and 200 to 200 and 200, okay? That's our goal. Well, actually, let's make it 1,000, I think. Nope, let's say 500. I think that should be good. Okay, so we want to move the X position from 100 to 500, okay? So that's our goal. So let's take a look at how we can do that. Let's attach a script. I'm going to make it built-in. We should already know what that is. Now, when we create an empty script, we have 2 things here. We have a ready function and a process function. Well, we can read the comments. They're actually pretty useful. The ready function is called when the node enters the scene on the first time. So this is basically only called once when I actually hit play. If I hit play, it's called. Okay. Now the process function, it's called every frame, and delta is the elapsed time since the previous frame. Well, what is frame? Well, frame meaning FPS, right? Frames per second, right? So how many times, I'm actually not 100% sure how many times per second this is called. You can probably find it online, but the basic idea is this is our tick that we were talking about. Now in here, we can actually move the position. So let's say self.position.x equals, nope, not equals, we want to add, so we can say plus equals 10. Now let's take a look at what happens if I hit play. Okay, cool. Well, that didn't exactly stop, right? Didn't stop at position 500. So we can actually add something called an if statement, and we can say if self.position.x is smaller than, we'll say smaller than 500, then we can say self.position and keep adding it to it until this is no longer true. Now let's hit play and see if this actually works. Awesome. Okay, now let's explain it. So the if statement here is basically checking to see if the position is less than 500, then we'll keep adding to it. If it's not, then we won't do anything. That's the way the code will work. Okay, so what if I want to slow this down? Well, what I can do is we say times delta, and this will make it actually go by the times of the delta that is called. Now, this is the way we usually put it in Godot. A lot of the time, we will use something called speed, and then we'll actually set a number to the speed. But we can see identifier speed is not declared. Well, we have two options. Either we can make this thing called a variable, call it speed, and say, let's say 20, and this should be gone. However, we don't want to make this speed variable every time we call the process function. We want to make it outside. So we can make it outside of the script right next to the extends script 2D. Now if I play, it does the same thing, but it's basically calling the speed times delta instead of 10, basically. And now we can change this to maybe, let's say 50. And we can see it's moving a little faster. Now, you might be wondering, well, what's the advantage of this, of using this thing called a variable? Well, let's say I have another thing here, right? I'm going to move the y-axis now. Well, I'm also using speed here. Okay, let's play. Well, what if I don't like this speed? Let's say this was 10, and I want to change this, well, speed. Let's say speed was 10. All right, I had 10 here. Whoops. And I had 10 here. Now, if I want to change the speed, I would have to change it in two places. That's not exactly optimal, right? That's going to take a while. Now, imagine you had this, but like 10 more times, right? Well, instead, we would just use speed, right? Now we only have to change it in one location. So we can change it to 100, and we'll see it goes faster in the X and Y, right? All right, I think that concludes our example. If you would like to try this in 3D, I would say go for it. However, we're not going to be going over 3D exercises in our assignment, so don't worry too much about 3D yet. We're going to kind of step into that in the 3D RPG section. All right, welcome back everyone to lecture 2.1, I suppose. We're going to go now over velocities and movement. So the basic idea is the same as wanting to move something from point A to point B. However, instead of using the position of something, of like A, we're not going to use position of X and Y. We're not going to exactly access these coordinates. We're going to use something called velocity. Now, what is velocity? Well, in physics, we're taught that velocity is something that we use to move, right, from point A to point B. And it doesn't exactly affect the coordinate system of us itself, but it does move us, if that makes sense. It's a little hard to grasp the concept of how it works exactly, but let's kind of look over some examples and see if we can understand it, basically. Okay, so in the X and Y coordinates, we have the same thing. We want to move this object from point A to point B, right? We want to move it from 10, 100
to 100, 100. Okay, so we have the same goal, but instead of using the position, we're going to use the velocity. So we're going to say self dot position. Nope, what am I saying? We're going to use the velocity. Velocity dot x. So we can see that it's pretty much the same thing, but we're just using the velocity. Now in this case, we can set it equal to a certain number, but generally speaking, we do usually add to it as well, or we can add to it in usually a small number. Now it's really hard to, I actually don't know the exact tick it takes to go from position 10, 100 to 100, 100. But we can kind of experiment in Godot and see the different velocities. And generally, it actually doesn't matter to know this or not, because the reason is, which you'll kind of see later, maybe in the assignment, let's go down a little bit, is when we have a screen, let's say this is actually let's have a PC screen, not an Android. This is mostly a PC course, which you can make it into Android games, but let's say we have a PC, right? Now, we usually have 1980 by 120, right? This is a high resolution screen. Now, in my pixelated screen, if I have, we saw in Godot, I think the default is it's a lot smaller. I don't remember exactly what it is, but I'm just going to guess, let's say 500 by 200, right? Now we can see these numbers are a lot smaller, right? So in order for us to move from this position to this position, it's a much smaller movement than it would be to go from here to here, right? So it really depends on the size of our pixels and our characters and the basically the asset pack that we use, right? So it depends on the art, okay? So we'll kind of look into how we can edit those kind of things later, but that's the basic idea. All right, let's take a look at an example in Godot. We want to basically use velocity now, right? But okay, well, let's take a look at adding a script first. Let's try to do this in the process function because we kind of know that we want to use the ticks. So let's say velocity, but we can see that it's not a thing. We're not able to create it. Well, this is because this node is something called a sprite 2D. Now, every node in Godot, every object has usually positions, right? Especially if it's 2D, it has an X and Y coordinate. Now, the problem comes in the fact that not every node, let me close all these, not every node has velocity. Now, which nodes have velocity? Well, if we go over here, you can see I cheated a little bit. We can go into nodes. We can go down into, where is it? Physics. Did I miss it? Oh, I think it's in here. Yeah. In the collision objects, we find physics body, and each of these have velocity. Now, which one do you think we're going to want to use? Most likely a character body 2D. So let's create this, and let's now take our node, our sprite, and move it into the character body, because we want this guy to be a child of the character body. Okay, now let's remove this script and ignore the warning for now. We'll go into what that is later, but in the character body 2D, we're going to add a script. Now in this script, we're going to create a node default. That way now we have this. If you don't have this, don't worry. You can just copy this code. We're just going to use the function process. Now in the function process, we can say self.velocity. Now let's say plus, or we'll say, yeah, we want to access the x coordinate. So we'll say equal to 10. Okay. Now let's see what happens. Nothing. Why nothing? Well, in Godot, we need to call something called move and slide in order for that object to actually move. Now we can see it's actually moving, right? And you can use the same if statement if you'd like. However, I'm not going to do that. I'm just going to keep this, okay? Now, what if I want to move downwards? Well, I can say velocity.y is equal to 10. Well, actually, I think, yeah, downwards is 10 because 10 is the positive and positive is downwards, right? Now, this basically gives us an idea of velocity. Now, what if I add?
If I say plus equals, this is going to, let's actually do the x so we see it kind of go across. We can see it's going to speed up. It's like an acceleration, right? Now, this can be helpful in certain aspects, right? Because generally, let's say, for example, when we fall in real life in physics, we have an acceleration, right? Earth has an acceleration of 9.8, and it accelerates us to the ground, right? That's how acceleration and velocity works in real life. So this kind of gives us an idea of how to emulate this in real life, right? Because now we can actually say velocity.y plus equals 10. Now let's actually take this guy, and if we use the move mode, we can see our character body 2D is actually up here. So let's reset this and move our character body 2D, put it up here. And if we click play, we can see it falls downwards at an accelerating rate. So let's actually move this upwards a bit more. And we can see it falls pretty quickly, well, relatively quickly. Okay, and that's how we use velocity to also add acceleration or gravity. Welcome back, everyone. This is the last lecture for this section of platformers. We're going to explore how to emulate a jump in real life. The first thing we need to understand is we want to emulate real life. So how do we do this? The first thing we need to do is let's draw out a, can I draw please? There we go. Let's draw out a floor. Okay, we have a y-axis. Actually, let's draw out the y-axis. We'll put it out over here. Okay, this is our floor. Let's say, obviously this is our x, this is our y up here. Now, we need to understand two things. We want to go up, and then we also want to go down. So you would think the first thing we need to do is the up part, right? But not really, because we're not going to really be able to go up without going down. So we need to add this downward. Well, what is this downwards thing? Well, this downwards thing is gravity, right? In real life, right, when you jump, there's this thing called gravity pulling us back down, right? If we jumped on the moon, which I think most of us haven't done, which maybe we would like to, maybe Elon Musk will allow us to go there, but the amount of force that pulls us downwards is less, right? The acceleration or the velocity in which we go downwards is slower on the moon than it is on Earth. So what is our acceleration on Earth? Well, it's 9.8. Technically, it's negative 9.8 because we go down, but in fact, this works out perfectly for us because positive is down. So 9.8, we'll keep it like that. So we want to add gravity first. So the way we do this in Godot specifically is if we have to check if we're on the ground, right? Because obviously on Earth, there's a ground below us, so we don't have to check for a ground, right? We physically can't go into the ground. But in Godot, we have to make sure we actually add that collision check. So we have to say if not, we'll say on floor, which we'll kind of go into how to do that in Godot later. Then we'll say add gravity. Now this thing over here is a way to add a comment. Now a comment is something that the computer doesn't read, but it's for us to read as humans. The computer will basically skip over this thing, and it allows us to write in plain English what the code does basically. Now comments are very good. They're very good to get into the habit of. So I'm going to try my best to add comments as we go along. Now, how do we add gravity though? Well, we want to move the velocity, right? So we saw from the last video, velocity. If we add, we'll say y, right? If we add to it, this creates the illusion, of acceleration. So we're going to add to it. Well, we can actually say 9.8, right? Or we can actually say a, which is acceleration. And this allows us to add gravity. Now, after that, we can add a check to see, let's say we want to check for input on our spacebar, right? We'll say space bar clicked, right? Then we'll jump. So we'll say jump. Well, how do I do this? Well, instead of adding to it, we actually can just set the velocity. So what we can do is say velocity dot y is equal to, let's say, 100. Except 100 is not right. You'd think that 100 is right, but actually it's negative 100, because remember, this is our negative, this is our positive down here, right? So if we want to go upwards, we have to add or subtract to our velocity. Now, the reason we straight up subtract, make it equal to and subtract 100 is because we're already adding velocity, first of all, and this will basically allow us to, well, jump upwards to velocity dot, the velocity dot y is going to be now equal to negative 100, right? But after that, obviously, I'm not going to click spacebar anymore. We're going to loop back around the code, and we're going to go downwards again, and we're going to keep adding that velocity again and be pushing our player back down onto the ground. So let's explain it one more time to make sure we all understand. Here's our player constantly being pushed down, right, with our velocity, right? With this part, we're being pushed down. Now, I'm going to set my velocity up here. Now, it's not moving my position. Now, if we were to use position and say position.y is equal to this, our player would instantly show up here. But we don't want him to just teleport, right? Unless that's what you want, of course. But we don't want him to teleport. We want the player to actually appear like he's jumping, right? And we do that by setting the velocity to negative 100, which we'll say is like right here. And then once he's up here, well, he's not actually going to reach this velocity or this position, right? He's not going to reach position negative 100, but we're going to set the velocity negative 100. So he's going to start moving upwards. And then at the same time, he's going to be being pulled down at the same time. So as he's jumping up, he's also being pulled down, right? As if this is real life. In real life, that's what happens. As we jump, we get pulled down at the same time, and we reach a peak, which usually is not the same number that we set, right? It's usually like a little lower, maybe like 20, right? 20 pixels upwards. I'm not actually 100% sure, but it's going to be something like that, right? So let's explore this in Godot and see how this can work in the engine. All right, now in Godot, here's where we left off last time. This adds velocity, as we can see, but we want to first add a check. We can say if not on floor, is on floor, then we'll add the gravity. Now, this is a function built into Godot. This basically checks for collision. Now, let's finish the code and we'll see why this doesn't work in a second. Now, let's say in order to add input, we can say if input dot is action just pressed, we'll say UI accept, which is either spacebar or the enter press key, right? Then we'll say self dot velocity is equal to, remember, negative 100. Now, hopefully our error, yeah, we have to access our .y. That's why we have the error. Here we go. And let's play. And if I jump, okay, let me actually move our guy over here. We can see we're kind of moving upwards. Right? Now, here's the thing, first of all, is we have no floor. And even if we did, nothing would happen because our player doesn't even have a collision. Now, here's our error. It's basically telling us we don't have a collision shape. So let's add a collision shape. Let's search up collision shape 2D, and we'll give it the shape of a ball. And let's make sure it's a child of the character body. We'll set the position to 0, 0. And let's make sure we make it as big as the picture. Now let's add a floor. Now in order to add a floor, we need something called static body. Now this static body will do similar things, but it's static, so it doesn't move. Now let's add a collision shape to this guy and give it a rectangle. And we'll move this guy over here. Okay? Now let's play and see what happens. And there we go. It's stuck, right? And we can jump very smallly. We can actually increase this to maybe 1,000. Maybe it'll be too much, but yeah, we can see it jumps up pretty high, but eventually it'll come back down, right? And we can see it comes back down pretty fast because the acceleration is pretty fast as well. Okay? Now, alternatively, you might have already noticed if we take off that script and we add a new script and we go to the template
we can see a basic movement script template. If we create this, we have similar things here. This is the gravity that we just added, and this is the input handle that we just added. But in this one, we also check to see if we're on the floor, right? This adds movement, but again, that's up to you to figure out how to do that. I would encourage you to try to understand this code as well, what is happening here. But yeah, that's the basic idea of gravity and velocity. Hello everyone, this is going to be the first video of our course. So if you're interested in what I'm talking about, I'm going to be creating a course, or the course is already released. This course is basically to take you from a complete beginner, from either someone who already has experience in Godot or programming or anything, into getting to the point where you can actually create your own game. And that is what we're going to be doing. So the first step or process is to create a platform game. So I'll be going through an example of how to set up a simple scene. We'll be going through some of the properties, and we'll also be going through some specific nodes that will be pretty important to the assignment that will be assigned later. All right, so the first step is to make sure we've imported our folder, and then we're going to create 3 folders to organize our game. Now, this is just what I've gotten used to. This isn't the default of every company, but this is something I do. So I'm going to create an assets folder, a scenes folder, and a script folder. This way I can keep everything organized, and it's very easy to just make sure I keep track of everything. So I'm going to make sure I take this asset folder and drop it in my assets. There we go. And I'm going to open up my reference project settings to make sure I get everything right. Now, we haven't created anything yet, and that's okay. What we're going to do is we're going to go to the top left, click project, project settings, and this panel should open up. Now from here, we can rename the name of our game or the actual Godot project, but I'm not going to do that. I'm going to go to the left side. Under display, I'm going to click window. Alternatively, we can also type in window, and window should pop up on the left. So now here, I'm going to make sure I switch this to 162, and the height is going to be 288. And then I'm going to go to advanced settings. And in order to test this and see what the difference is, there is override, but we're not going to touch that just yet. Let's close this, and I'm going to play. Well, we actually need to create a scene to play. So what we'll do is we'll create a 2D scene, and we'll save this as our main. We'll just say main, and we'll put this in our scenes file. Let's save. Let's click play again. We'll select current, and here we go. Here's our window. Now this happened because we made our window a little smaller. Now what happens if we change our override? Well, what I want to do is I actually want to take this, and I'm going to double it. You can do that by saying ×2. We can take 162 and say ×2. And now let's actually go down a little bit more. Under mode, we're going to keep it, or we're going to select canvas items. And I'll explain what that is much later on. But for now, let's see what happens. Our window is now bigger. So the override, what it did is it basically made our window bigger, but it didn't make our pixels bigger. So if I were to have an icon in here, let's drag our icon in and see the window screen. It covers pretty much all of it. If I play, it doesn't matter how big my window is because this will always stretch. Now there's one other thing that we have noticed is that this guy is a little pixelated. Now let's go into our project settings one more time. We're going to search up filter, and it will be under texture. Here it is. And instead of linear, we're going to select nearest. And we're going to close. And now we can see it's no longer, well, it's pixelated, but it's properly pixelated. All right, so let's delete this icon by selecting the icon node on the top left over here. And I'm just going to hit delete, and it's going to say delete node. And I'm going to say OK. Awesome.
from here, we're gonna get started on the player and the ground. So let's add the ground first, because I think that's relatively simple. All we really need is something called a static body. So if I search up static body, we will find static body 2D, and we can hit create. Now, if you're confused about how to add nodes, you can hit the plus button, which is how I usually do it, or you can right-click the node that you want to add to and hit add child node, or Control A, supposedly. And now we're going to add a collision, because we need a collision shape for this guy. Now we're going to take the shape and we're going to select a rectangle. Now we have a few options on the top of what to do. Now the first default one is the select mode. This allows us to kind of move things around, right? We can move things, we can stretch things. It's kind of cool. I'm just going to Control Z. But what I want to do is I want to take my static body, the actual body, and move it. So I'm going to do that using move mode. I'm going to take this down here, and we'll go back, select the select mode, I guess Control drag. I'm not sure how you would do that, but that's okay. We're just going to take our collision box now and drag this as if we had a floor. Now we're going to save. And one other thing that I want to make aware, or you aware of, is grid snap. I use this quite consistently. I will turn it on and off depending on what I want to do, because now we can see if I want this to snap into our screen, it's quite easy. However, you can see that it's kind of a pixel or two away, so we're going to turn it off and put it in. And there we go. We can now see it's pretty much pixel perfect. All right, there's our floor, but if I play, I can't see anything. Now, there's one option in the editor, in the debug, there's an option called visible collision shapes. Now, if I select this and then play, I'll be able to see my collision shape, but that's not really what I want, because when I'm actually playing my game, that's not really what I want. I'm going to turn this off, but do keep aware that that is there. What I'm going to do is I'm going to add a panel, and I'm going to use this as my floor. So I'm going to take my panel and stretch it. So now when I play, I'm able to see some sort of floor. I'm going to stretch it a little bit more so it doesn't look very weird and is sharp on the edges. All right, let's minimize that by clicking this guy over here. Now I'm going to add my player by adding a node, and we're going to search up character body, if I can type that correctly. Character body 2D. There we go. Now we want a few things here. We want a collision shape, and we don't actually have to search anything up because in the recent, we see we have a collision shape. So let's hit that and create, and we'll give it a collision shape of, maybe I'll say a circle. Actually, yeah, we'll give it a capsule. I think our players are usually capsules. All right, so let's zoom in a little bit, and let's actually take our player and move him into the middle of the screen. There we go. And in here, we want to add our image of our player, right? So let's go into our assets folder and find our player. Here we go. We can go into here, character, PNG. We can select this one. Now we see that we have a bunch of different things. I'm only going to use this guy. So I'm going to take my body and pop him in to this. Now here we can see that our body is not actually a part of our character body. So we want to actually take this node and drag it into our character body 2D. Now here we can go to our character body 2D, or our node that is now body, and we're going to go to the transform. Now we can see the position is 3 and -3. This means it is not centered from the character body. So whenever the character body moves, this node is always going to be off center. So we're going to reset it at 0, 0 by clicking that little loop thing. Awesome. Let's save and let's play and see what we have. Okay, cool. We have nothing. Well, what do we do now? Well, we want to add a script. So in our character body 2D, let's actually rename this to player. And we're going to hit add script. Now here we have character body basic movement, I actually do suggest that you take a look at it and try it, but we're going to do it from scratch. So we're going to select default, create, And now we have ready and process. Now, in our process function, we basically want two things. We want one sort of code that will allow us to add gravity. So let's comment that. So let's say add gravity to the player. And then we want another function or some sort of code that will allow us to move. So move player left and right. Now in the add gravity to the player, what we want to do is there's something called velocity, and our velocity consists of an X and Y axis. Now the way this works, let me pull out Paint. The way this works is we essentially have an X and Y axis, right? This is the Y axis and this is the X axis. Now don't worry, we're not doing any complex math. This isn't calculus. This is very simple. On an X and Y axis, we generally have 1, 2, 3, etc. Correct? And this is usually the positive. So this is 1, 2, 3, etc. However, there are two things to note. In Godot, the y-axis is reversed. So this is all negative. In fact, we can go to our 2D space and we can see on the left side, if I zoom out, you can see over here, it says negative 200 on the left, correct? And the y or the x-axis is normal, right? The right side is positive and the left side is negative. Now going back to our paint, what we want to do is we have our player here, right? So there's our little stickman player. We want to make sure that our player goes downwards by adding gravity. Now, how can we do that? Well, through code, we usually can access the gravity or velocity by actually just typing velocity. And it even helps us by completing it. Now, velocity consists of something called a vector 2. This is called vector 2 because we are in a 2D space. Now, if I was making a 3D game, I would be using vector 3, right? So up here, outside, I'm just going to type in vector 2. We can see that it's called vector 2. Now, this consists of an X and Y coordinate. Now, if I want to access the Y coordinate, I can either access it through vector 2, or I can just say velocity.y. Because I know that this velocity is a vector 2, I can say we're going to access the .y. So we're going to delete this. Now, I'm going to ask you a question. You're going to try to guess. When I want to add gravity, thinking back to my graph, do I want to add velocity or subtract velocity? Hopefully you've answered the question and guessed that we actually want to add velocity because the top side is negative. So we want to go this way, right? Because if we were to subtract, we would be going upwards. So what we're going to do is we're going to say plus equals, let's say 200 times delta. Now, what is delta? Delta is this guy. The delta is called every frame. It says right here, called every frame. Delta is the elapsed time since the previous frame. Now, basically, it's a very fast function that is called very consistently throughout our game. Now, we're going to actually do this because, actually, let's test this and see what we get. So let's play. And nothing happens. Oh my gosh, why is nothing happening? Maybe we actually have to have physics process. Let me double check this. No, we don't. All right. I believe we need to actually add this next piece of code. Otherwise, it's not going to work at all. So we actually need to check if we're not on the floor. So we're going to use this function called isOnFloor, and we're going to say not. Now we can either type not, or we can say this exclamation mark. This exclamation mark is basically the equivalent of saying not. So let's play and see if this works. Okay, it is not working. So strange. All right, I'm going to try to figure out what is going on. I actually think I'm going to try this one last thing. And if this doesn't work, then I'm not sure and I'll have to pause. Okay, never mind. I just remembered why. Sorry about that, guys. Okay, so in a body, we need something called move and slide. That is why our player was not moving. So move and slide, we can actually hit Control and left click, and this will give us a description of the function. But basically what it does is it actually allows us to use velocity. Now, okay, this was a rookie mistake on my part. If I actually removed all this and I used position instead, and said gravity times delta, this should work. Except I have to say .y. Yeah, that should work because the position can always be used and adjusted. Now, velocity cannot always be used, or it can only be used if we're using move and slide. Okay, that is why it wasn't working before. So here we go. We now added gravity to our player, and we can now move and slide, and our player will hit the ground. There we go. Now you can see that it hit the ground kind of in the middle. That's because our collision shape has not been changed. Now I want you to try and change it accordingly. So I'm going to actually reset this to a rectangle, and I'm going to adjust this like so. Awesome. So I'm going to zoom out. I'm going to go back to my script, and let's complete this move player left and right. Now this is actually pretty easy because what we can do is we can just get the direction by using something called get axis. Now, first of all, we want to basically set the direction by saying variable direction is equal to the input of dot get axis. Now, this get axis is basically going to be using this idea of the x-axis of whatever I give actually, right? So the left and y are my essentially left, the right x and the left x, right? So when I click on the right on my keyboard, right? So if I click right, this will actually return me vector 2, 0, 1. In fact, to test this, what we can do is we can say print direction. And if I play, it'll print me 0. Right now it'll print me 0 because I'm not moving. Now if I click right, it's giving me 1. Now if I click left, we can see that now it's -1. So now what we want to do is we want to use that to see if, okay, well, now what do I do, right? Now I want to move. Well, the first thing I can do is I can say if direction is just valid, then we'll actually do something with it. Well, what can we do? We want to move our velocity, right? So maybe let's copy this and change this to x. But we don't really want gravity, right, for this. We want a different sort of variable for this guy. We want something called speed. So we're going to create a constant up here called speed and give it a value of 100. Now, the reason we're making it constant is so that we make sure that this never changes. A constant is something that can never change, whereas a variable can change. Okay, so let's go over here and give it an else function. And this is basically going to allow us to check if the direction is valid. Then we'll do this. If not, then what are we going to do? Well, we want to move to 0, right? So we can actually just do that by saying, here we go, velocity x is equal to 0. Now, one thing to note is, first of all, this is going to add, right? We don't really want to add to our velocity. We want to set it equal to the speed times our direction. So let's actually say direction times our speed times delta. Now, actually, let's remove the delta there. We don't want the delta. We just want speed times direction. And let's play. And now we can see when I move, we go right and left, and it works pretty nicely. Now, what about jumping? Well, this jumping is actually pretty simple. I want you to try to figure it out first, but if not, that's okay. You can keep watching the video and we'll figure it out together. Okay, so let's add a comment over here saying check for jump. Here, we can add a check of input. Now, how do we do that? Well, we can do that by saying if input dot is action just pressed, UI accept. Now, UI accept by default is the spacebar or enter, I think. It's either spacebar or enter or both. So I'm not 100% sure, but I'm pretty sure that's the default. Now, here, if I press spacebar, what I can do is I can Well, I want to jump, right? Now, how do I jump? Hopefully you probably guessed I want to change my y velocity. Now I can do that by either adding, subtracting, I don't know, what do I want to do? Well, you'd think maybe we want to subtract. But in reality, what we can do is we can actually just set it to 200 or some big number. Now, what I'm going to do is I'm going to set it to negative 400. Now, why negative? Well, if we go back to our paint, remember, let's say we're on the floor over here, right? And I want to jump. Well, I wouldn't set it at 400 because 400 will be down here. So I want to set it to negative 400 because negative 400 would be somewhere up there, right? Now, back to here. There's one more thing we want to do, but I want to try to let you guess what that is because there's something missing from our if statement. Let's try playing and see what we have. Well, I have a jump. But what happens if I just, whoa, I could keep jumping. Well, that's kind of cool. I can infinitely jump, and maybe that's what you want, but maybe it's not what you want. So what we can do is we can add an and statement here and say and is on floor. So now when I play, I can only jump if I'm on the floor. So I'm trying to spam it, but it's not working. So there we go. We now have some nice movement, and I can even move in the air. And we have some nice platform movement. Now, I want you to try to experiment with this. I have a question, I suppose, after this video that you can try. Let's say I don't want to move while I'm in the air. How can I change that? I want you to try to edit your code so that your player does not move while you're in the air. Awesome. That's the end of this tutorial. If you guys enjoyed this tutorial and found that you learned a lot, I would love if you guys checked out my courses. I have a few courses on Udemy. I have a big course coming up soon, and that's what this video is about. And it's not even about it, it's supporting that course. The basic concept of the course is to basically take you through a bunch of exercises, and it goes through a 3-step process from understanding the concept of what we're learning, and then it goes through the example, and that is what this is. This is the example of that course. So you have 1/3 access to this course basically, and the third part is the exercise. Now, I asked you a question in the end of this video, and that is basically what the exercise is. So it's going to take you through a bunch of questions and things that will help you learn by asking you questions while going through things. So if you guys enjoyed this course and my questions and the way I kind of explain things and whatever, I would love if you guys checked out my courses. If not, that's okay. You can keep, just hit that subscribe button down there, and that can also help me so much. And thank you so much. I will see you guys next time. Welcome everyone to your first assignment. I'm very excited to bring you this assignment. Hopefully it will go over quite a few things and guide you through creating a game. It's going to be your very first game that is unguided. So you're not going to just be copying people. You're going to be doing your own research and trying to figure things out on your own. But of course, the assignment will guide you through that. So let me show you a quick gameplay of what the game should look like. So here's the game. Obstacles should spawn, and I should be able to jump over them. Let's see if I can jump over that one. And if I hit one, I disappear. So the player cues freeze, essentially. He disappears, right? He dies. All right, so let's go over the assignment. I'll try to go over it relatively quick. I'll try to make this a shorter video, but I'll go into detail as well in case anyone needs any help. So game overview should be an infinite scroller game. If you want more references, there's examples, Flappy Bird or a Chrome Dynamo game. I include some screenshots as well. So the project structure, I actually go over this twice. It's relatively important that you understand why it's important to structure your project in folders like this. Now in this one, I don't have subfolders. So for example, in the scenes, if I were working in a bigger game, my own game, I would have subfolders for the scene. So I would have another folder that's like for levels, or another one for the player specifically, because a lot of the time the player will have quite a few scripts. Well, I guess I would put it in this one, right? But yeah, so in this game, there's not that many. There's like 3 nodes and 3 scripts, right? Assets, not that many. So there's not that many, but it's a good habit to get into the habit of organizing your project properly. Now for the player, I explain of what it should contain and what it should have for the script. So it should implement keyboard inputs so the player can jump. Again, note that the animated sprite is a bonus. It's in the bonus on the bottom that we'll check out later. The background should use a parallax background and parallax layer to create an infinite background effect. Okay, so I want you to kind of search this up, use external resources to figure this out on your own. There is a script, so that's kind of a hint. So try to figure that out on your own, and hopefully you can figure that out. It's very easy. So, if you need help though, just don't try to reach out. That's my point. Try to reach out. Don't worry about feeling bad. Just try to reach out and ask for help. For the obstacle, I want you to go through this, but it gives a pretty detailed description of what the obstacle or /box should contain. Okay, I'm not going to go over it right now, but if you have any questions about this, definitely ask. And as a bonus, this is stuff that is not provided in the solution. It's not in the project solution, nor is it in the video solution. So this is stuff that you might want to do. Well, I guess the animation is, but if you want to do this on your own, go for it. I really do encourage this, especially when the assignment is done. Okay. And I add a bit of note what this is like. This is more for first time reading through the assignment and understanding what the point of this is. Now, under this, now that is basically it, 3 pages to understand what the assignment is. Now, under this, there's just more help, basically explaining if you need more help, what you should do for certain things, the scenes, project settings, and then on the bottom, there's also recommended nodes. Now, these give a little description of each node of what they should be. These are also included in Godot, so, these aren't like magical things I've just created from nowhere. You can find these anywhere, but these are the nodes that you should use in this project specifically. And I would recommend that you get familiar with most of these, right? So what's the difference between a node and a node 2D, character body, et cetera, et cetera. Some of these you might not even use, and that's okay. Like for example, the camera 2D, I would recommend you get familiar with it, but it really depends on how you set up the project, etc. So don't worry if you don't use any of these, like the panel or the camera 2D, the canvas layer, right? So etc. All those things, don't worry if you don't use them. That's totally okay. And that is pretty much it for the first assignment. I wish you luck. This is your first assignment. Do try to do your best. If you need any help, I have a Discord, obviously, which hopefully most of you know. So you can go ask in the Discord. If you want access to the premium section of the Discord, where I am kind of more active and I will make more of an effort to help people in there, you can either sub through my Patreon or through my Twitch. I think my Twitch is not at the moment subbed, so I don't have the option to subscribe there, but eventually, once I do, you can subscribe through there, and you will have access to the premium section on our Discord. Basically, it's just the subscriber section, essentially. And what else? I think that's it. I wish you guys luck. Yeah. If you need any help, again, don't hesitate to reach out. This is a relatively easy assignment. It gives you quite a bit of guidance to figuring this out yourself. And of course, I provide a solution. Now, try not to watch the solution video before trying this on your own. Please try this on your own first and then look at the solution. Okay? This is really just for you. Like if you watch the solution first, you won't learn as much. You might learn a few things here and there, but you just won't learn as much if you just try this on your own. In fact, if you're really, really struggling, okay? If you're really struggling and you just can't figure anything out, try this. Go through each step. Well, maybe not the game overview. Let's go to the player. So go to the player and go through each step and then try to figure it out. And if you can't figure it out, that's okay. Watch the player section of the video. Watch that section of the video where I explain how to create the player, right? And then stop the video and then go to the next section. Now try to figure out the background on yourself. Okay, so try to figure out each section on your own. And if you can't figure it out, that's totally okay. And just go watch the video, okay? If you can even figure out like 2 out of 3, that's awesome. I don't expect you to get everything perfect, right? 100% is really rare, but if you can figure out 2 out of 3 or even 1 out of 3, that's good. That's really good. That's a good step in the proper direction, okay? So that's it. I will see you guys in the solution. All right, welcome everyone to the solution set of your first assignment. This is my third time recording, so hopefully I can finally get this right. But we're going to get to the player. So we're going to do the player and I believe the background a bit in this video. So the background will be relatively simple and so will the player, but let's get right into it. So I've already set up the project settings, but I'll show you what I have. So in my filter section on the bottom, if we go to texture or just search up texture or filter, we'll find the default texture filter and we're going to set it to nearest. All right. Now in the Windows tab on the display, I've set the width and height to these numbers and the override to these numbers and the stretch mode to canvas items. Okay, I just double checked I'm recording and I am. God bless. All right. So here is our scene that we want to create. Okay, so let's create a node as our base scene. Now let's save this as world, and we're gonna put it into our scenes folder, okay? Now, again, remember to actually have these folders when creating your project, right? So in our world folder, let's actually rename this to world first. In here, we wanna add two things. We wanna add a character body 2D, and we want to add the floor, which is going to be static body. So let's actually leave that for now and work on the player. So let's rename this to player. We can rename this to floor. Now in our player, we want two things. We want a collision shape, and we also want an animated sprite. Now I'll show you how to set up the animated sprite, but in the engine itself, but I want you to try to figure out how to add it into the code. Okay, so in the animated sprite, on the right hand side, we have the animation. We're going to open these sprite frames and add this. We're going to click this sprite frames and this should pop up. Now we're going to click or type in run, and we're going to click this little guy over here, the add frames from sprite sheet. If we click this, you'll have to find, well, by default, you'll probably see this. If we find the main characters and find whichever one we want, we have the run. If we click this and zoom in by control zooming, we can find that the vertical, we want it set to 1. And then the horizontal, we want it 12. So now we can select all the frames and add these frames. Okay. And now if I hit play, we can see my player running, but it's kind of slow. So I'm going to set this to 15 frames per second. You can do 10 or whatever you like. It's up to you. So I'm going to pause this. And now I'm going to set a collision shape for this guy. So let's give him a rectangle and maybe make this a little lower. I think that's good. Let's zoom out a little bit. Now I want to lock the collision shape and the animated sprite. Now instead of going to each one of these and hitting the lock button, I can actually select two nodes at the same time by hitting control and selecting it. Now I can lock these and I can move my player. Oh, that's my floor. I can move my player without moving these. Now for the floor, we're going to do something similar by adding a collision shape. So let's add a collision shape by adding a rectangle and just dragging this out. And here we go. There's our collision shape. Now for our player, we want to add a script. Now we don't want it to add it to the scenes file, so let's actually add it to the scripts file. Let's open this, create, and here's our script. Now if I hit play, we'll select current because we're in the world. You can see that we can move around, and there we go. Now he's not playing anything, so what we can do is go over here and hit the auto play on load. And we also don't want this player to be local anymore. We want to save this scene as the branch as a scene. So if we right click the player and save branch as scene, it'll allow me to save the player in a new folder. So I'm going to save it in my scenes folder. And there we go. We now have our player in a separate scene. So I can open up this player and edit it if I wanted to. So in fact, I'm actually going to reset the position to 0, 0. I'm going to close the player and I'm going to move my player once more over here. And now let's edit the player's code because as you might have seen from the assignment, we don't want to move right or left. So we can actually delete this code over here. So let's go back to our player. And if we play, we can see this is pretty much what we want. Now we just want a background. We also want the floor to have some sort of thing, right? So let's add a panel to our ground. And this will be our ground. It's not very pretty, but that's okay. Now we can add a parallax background, and a parallax layer. Now there's also something called a texture rectangle, which we can add, that is very good for basically taking, let's say, the green background and just extending it like this. And you can play around with this, but you can also change the expand or stretch. So we can kind of play around with these, or instead of scale, we can say tile. Instead of tile, we can say keep. Well, keep, we don't want keep. Probably want, most likely, we'll want tile. Now, I want to duplicate this infinitely. Now, how can I do that? Well, in my motion on the parallax layer, we'll go to mirroring and select 160. And then for the Y, we'll put 1. The reason we put 1 is because we want the Y, or the Y to duplicate once, basically, or to just be there one time. Now, obviously, it's not super pretty here, but that's okay. I think we can actually put this to 160 right there, 162. You can kind of duplicate it like that, or you can kind of play around with this and adjust the background how you like, but this is good enough for me. I'm not going to worry too much about the background and how pretty it looks. All right, now if I hit play, we have a background, we have a ground, I can jump, but the background doesn't move. It doesn't give that infinite loop effect. So in our background parallax layer, we're going to add a script to this. Now I'm going to make it built in, and I'm going to hit create. Now in this script, we want to add two things. We want to add a variable that is exported and name it scrolling speed. Now, export means if I go back to my scene and I click the parallax background, we can see over here on the right that we have a built-in script of scrolling speed. And now we can adjust this to however we like. But I'm going to keep it at 100, but I would suggest you play around with this number, okay? Now, one other thing we need is to actually move the background with that speed. So we'll add a process function again and say the scroll offset dot x, we're going to subtract and equal scrolling speed times delta. So now if I hit play, my background will actually look as if it's moving, and it'll keep infinitely looping. Awesome, we've created the background and the character. That is it for this part. The next part will go over the obstacles, so good luck. All right. The next part is to create the obstacles. So first, we actually need to create the obstacles. So we'll create that in a new scene. We're going to create a static body as the main node, as I kind of already said. Now, as we go along, I'll kind of mention we don't actually need it to be a static body, but it's okay. We're going to do it anyways. So let's add an area 2D. Let's add a collision shape to that area. And then we'll also add it to the static body. So now we get rid of all the errors, but now the collision shapes need, some collision. So let's add that. Let's add that. Now, don't worry, there's one more thing we need, right? So we need to add the obstacle. So let's go find that. Should be in traps, I think, maybe. Could use spikes. Yeah, let's use spikes. Why not? Okay, here we go. Here's our spike. So we'll put it right there. Now, for the static body, this is the area body. So let's kind of put it like that. And then this one, we'll make it smaller than this. Now, this is something you would only know if you experimented with it, but the static body must be smaller than the area 2D. If it's not, the area 2D will not be able to detect anything. Okay? So let's let's rename this to spikes. Let's save it in our scenes folder. Awesome. And let's add a script to this. Now let's add it to our script folder. And here we go. Let's open, create. Here we go. Here's our script. Now there's a few things we need. We need to add a speed variable. And then we need to add a process function that allows us to actually move this spike. Now, the reason we're subtracting to the speed is because we want it to go to the left. Okay, so we basically want the spike to spawn here and go to the left. Now let's add a node in our main world. Let's add a regular node. And in here, let's add a spike just to test it. So let's go over here to spikes. Let's add that in there. And if I move this down a little bit, here we go. Let's spawn it. Or let's play and see what we get. There we go. There's our spike. We can obviously jump over it, whatever. Obviously, it doesn't work yet because we need to connect a signal to our spike by going to over here. We'll say if body entered, go over here, connect it. Now in here, we need to do two things. We need to delete the body that entered our area. However, we need to make sure that body is a player. Now, how can we do that? Well, we add something, say, by saying if the string, the name of the player, is in the body.name, basically saying, hey, in this body that we just hit, is there such thing as a player in the name of it? Well, there's two problems here. Well, two things to note is this is capitalized, okay? Now, if we go back to our world, we have to make sure that this capitalized P is capitalized, okay? So the player is named player, right? That's the body. And so this should go off. So let's try it. Let's click play. And we're not going to jump. We're just going to let it hit us. And there we go. We got deleted. All right, so let's delete this spike because now what we want to do is we want to randomly spawn these spikes. So let's add a timer node because this is something I kind of said we needed. And here in our node, we're going to rename this to obstacles. And let's add a script to this in here. Scripts, open, create. And in here, we're going to want to spawn the objects. So first we need to preload the objects, the spikes. So in order to preload something, we can take our spikes on the bottom left and drag it in, and it'll give us the path. Or we can right click this and copy path, or Control-Shift-C, as you can see. So if I copy the path and I paste it, we can see the path is pasted, right? All right, there's one more variable we need. We need something called RNG, or a random number generator. Now, there's a lot of different ways to randomize things in Godot, but this is the way I generally do it. Now, we're going to also connect the timer by signal. Now, we basically want the timeout signal to connect to us, right? But there's two ways to do this, actually. There is by connecting it directly, or we can do this. We can say the timer .timeout.connect on timeout. Now this, it's giving us an error because we don't have a function called timeout. So down here, if we create this function, the error will disappear. Obviously, we have a new error. We need to keep typing code, right? So let's do two things. First off, we want to spawn the object. We want to create the object, right? The box, right? So here we'll say, let's change this to spikes and spikes, and we'll say spikes temporary. Okay, this is going to allow us to actually create the object in our hand. Okay, now we want to also add that spike into our obstacles, right? Now in here we can say add child spike temp, right? We want to add it to ourself basically. So generally we would do it like this, or we can call a specific node and add it in that specific place. Now there's two problems here. First, we want to adjust the position, but we also want to randomize the position a little bit. So first, let's create a random position between 100 and 140. This is going to be for X value, okay? Now we'll actually set the position of the spike temp that we just created. So here we can see that we created the spike in our hand, and then here we're gonna just edit that spike, okay? So I actually have to test this and make sure we're spawning it in the right Y coordinate. So I wanna spawn it right around there so we can double test it and see that it's 222. So let's go back here and change this to 222. Now, the 100 to 140 will basically allow it to spawn anywhere from here to 100 to 140, right? So it'll spawn anywhere between here, right? So it randomizes it a little bit. All right, so back to our timer. Let's actually change this to 2 seconds. So it's not spawning that quickly. All right, and let's play. And I think that should work. So let's give it a try. Ooh, it won't work because we need to start our timer. We need to put on auto start. So let's play one more time. And once it goes off, it'll spawn the spike and we can jump over them. And if we hit them, we die. Awesome. So that is it for this assignment. If you want to play around with this, like honestly, what I would do is probably scale this to 2 because they're really small. So I'm going to scale them. Let's play one more time. Let's see how big. Ooh, that's really big. Okay, maybe that's too big, but those are things I would play around with. I would probably play around with the floor, make it look more pretty. Again, remember that there's bonus things to this assignment that you can add. So there's like pause menus, collectibles. Hopefully the collectibles, you should be able to do that. The collectibles are basically the same idea as the spike. However, instead of killing the player, we should have a variable that we add to, right? We should have like a coin collector basically. So it's the same idea. Hopefully you can try to figure that out. The coins, you could actually do the exact same. So you could have a timer, an obstacle, and spawn them in. You can also delete the spikes when they go off the screen, right? So you can check for that. There's a lot of things that you can use to optimize the game. So that is pretty much it for this assignment. I hope you learned a lot. I hope you take what you learned and apply it into the future assignments, because these assignments will get gradually harder. I will kind of guide you less and less into the assignments. So try to make sure you understand a lot of the concepts and things that we went over in this, I guess, chapter or section of the platformers. Okay, so good luck, and I will see you guys in the next section for RPG.